dear colleagues, that I have to say, and that's my presentation. But I have got a little bit more. So let me just go right ahead. So I've called this Risk Assessments, Professional Duties and Other Disasters, a Guide for Young Professionals. The reason I called it this is often people talk about professional standards and what have you, but they don't really make it something that's understandable and understandable for us as individuals. So I'm not going to talk to you today about your company or your university or anything like that. I'm going to actually just talk to you. So to you, the professional who's out there doing tunnel stuff. All I'm going to suggest is that you as a professional in this area need to exercise what I'm calling reasonable care and skill. And the reason is, in the underground, as we know, you can kill people really easily and injure them even more easily, damage a lot of property, not just the tunnel, but other things that are around it and things that are in it. And of course, lots of economic loss. So actually, we choose to play in a quite risky environment. But for me, I mean, I love all of that because of the benefits that the underground brings. This is my diversity statement. A lot of people talk to me about my pronouns and whether I'm a him or a her or whatever I am. So I'm saying I'm a him, and that's my wife there, and I grow flowers, and I unashamedly grow flowers, and I drive trucks. So if you're wanting a professor who only does professorly things, that's not me. I have other things I do. So, and I, particularly during COVID, where I couldn't travel, I was probably the most highly qualified truck driver in Australia, and I loved it. So there you go. So risk management. What's this? What am I going to talk to you about? Well, I'm going to talk to you about how we build these things. And I'm also going to talk about how we operate them, because actually it's not just the building that's a bit risky, it's also the operation of them. And when I'm talking about risk, I'm talking about the possibility of losing something of value. And when we're doing what we do underground, we do it, and we do it knowing that there are a big range of risks down there. And we know that it's more dangerous than if we took up being librarians or, some other, nice job up on the surface. We are risk takers. It's just the nature of what we do. And the way we do this successfully often has what's called a risk management framework or method around it. I mean, each time we build a tunnel, we don't just go out with a digger and start scratching around and seeing if we can do it. We've got some experience at this, and we've learnt from previous activities, and that process of learning and changing the way we do things and consciously doing it, for me, I call that risk management. Whether it's written or not written, it's risk management. And I'm not sure, but I think I can hear someone ordering their biryani or something there. So if you could turn your microphone off, that'd be really good. Otherwise, I'll have some biryani as well. So whoever it is, turn their microphone off. So in terms of this risk management, managing the risks to yourself personally is fundamental. As I said, I'm talking to you, like each of you. I'm not talking to your boss, and I'm not talking to your company, and I'm not talking to anything else. I'm actually talking to you and how you manage it for yourself. And sometimes that's not done. Often in business and generally as we work, people talk to you as if you're part of a big machine and how you look after your company. I'm talking to you as a professional. And the reason I'm talking to you is, in my day job, I investigate disasters. And what we're looking at here is just a small bit of rock that's fallen from the roof, and it's killed a whole lot of people who are underneath that. And my job was to investigate how it is that those people died. And so I'm very sensitive to how really not a big problem in geological sense can be a really big problem in a human and professional sense, because it doesn't take much to kill somebody. And operationally as well, I've been asked to give advice in Saudi Arabia with the Hajj and what have you. And here's a tunnel which normally would be a road tunnel, and everyone's going, of course, it's the Hajj, so lots of people walking through the tunnel. But unfortunately, when things go wrong, they really go wrong. And it's so in construction, you've got the issue of collapses, water ingress, getting hit with vehicles, all that sort of stuff. And then in operation, depending upon the nature of the operations, you've got the risk of a lot of people dying as well because it's a confined space. And I'm going to revisit these two events later in the presentation. So I've got to really put this in perspective too. So as you heard in my introduction, I'm originally a scientist. I'm professor of engineering in Japan, and really the scientist in me tells me that engineering isn't really a science, right? It's more like cooking, and I don't mean to be offensive, but I think the engineering approach is what's called heuristic, which means you're practical. You employ practical techniques, not necessarily the best, not necessarily perfect, not even necessarily logical, not even necessarily rational. But however it is that it happens, you get to your immediate goal. So that might be your rock bolting strategy. It might be your lattice girder strategy. It might be your shotcrete strategy, whatever it is. Mightn't be perfect, mightn't be optimal, might use more material than you should, mightn't seem logical, might in fact seem ridiculous, but it works. So heuristic, what we do as engineers, it's practical stuff. And when we're building tunnels, we normally don't have the time to find the optimal solution. And so this practical solution can really help us get things done. And other ways of describing it are rule of thumb, educated guess, judgment, right? All that sort of stuff, common sense. Now, I know for many of you, you'll probably say, oh, that's not true. We're really, really precise. We do all these calculations, blah, 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 blah. Have a bit of a think about it, how precise your calculations are. And I betcha, and if I'm wrong, next time you see me, I'll buy you whatever it is you want me to buy you in the cafeteria. You'll find that usually the calculations we make are within an order of magnitude or two. Our lining thicknesses, our support system, our drainage system, our whatever it is, it's not necessarily perfect, but we know it's going to work. Now, this is important because it means that for each of you as individuals, you've got to know what, as a rule of thumb, looks about right. Because if something goes wrong, other people are going to say, yeah, that's right. Yeah, I would have done it, something like that. Or they're going to say, what on earth were they thinking? And so I want you to remember, you want to be within the boundaries of a heuristic method. That is, within the boundaries of a problem-solving process for you underground, that your colleagues and other experts will say, yes, that sounds correct. Yeah, it's true that it collapsed, and yeah, it's true that there are people dead, and it's true, blah, blah, blah. But you know what? What he did or she did or they did seems about right. I can imagine I might have done it that way as well. So engineering, heuristic, it's not like down to the 0.00, in terms of tolerance and what have you. So my understanding of in India is that, and this is of the Indian legal framework, and I'm not claiming to be the expert on Indian law, and my understanding is it varies from region to region, but as a general rule, if something goes wrong and and I'm talking you individually, remember I'm talking to you as a person, if you acted in accordance and in a manner which is widely accepted by your peers at whatever time it is, like right now, 2023, this is what we do around here, and you're able to demonstrate that you've turned your professional mind to it, and you haven't sort of gone a bit crazy and done something that's irrational, then you're going to be in a very good position to defend yourself or whoever's helping you to defend your position, because you just say, look, I'm an engineer. I've done it to the best of my ability. The practice that I've used is widely accepted practice here. It's what we do. It was appropriate for these circumstances, and there's nothing about the way I've done it that suggests I've stepped outside that. That's what I want you to remember. Okay? So I want you to have the strength to go out there and do your underground construction or operations, knowing that if you do it the proper way, and what I mean by that is the way that is generally done, so that your peers will be saying, yep, this is right, you're in a really good position. And there's some examples. I'm going to just cite something from the law that express it. So basically, in our legal systems, whether it's the Indian legal system or our legal system or whoever's, it's certainly in the types of legal systems that we're familiar with in our countries, it doesn't matter so much that you're wrong, so long as you were wrong for all the right reasons. So you can be wrong as long as you got it wrong for the right reasons, and you've got to be able to demonstrate you're acting in accordance with widely accepted, competent professional practice. And in a court case, which isn't from India, but I think expresses it quite well, it says, look, back in the olden days, so back in the 18th and 19th centuries, competent professional practice as a medical person was to administer lime juice to treat and ward off scurvy amongst sailors. And that practice was well before anyone had an understanding of vitamins in human health. So it didn't matter that no one really understood why it worked. What mattered was that it did work. And so even if the practice had no good explanation, it was still the correct practice, even if no one understood really why. So in engineering, when you learn how to do something, particularly in the underground, it might be an older person or a more experienced person saying to you, look, if you feel the rock, certainly when I first got into the underground, the very experienced people tell me to put my hands on the rock and just feel it and just listen to it and it'll talk to me. And of course, later I started to get a conceptual understanding of what was going on, but listening to the rock and being respectful for the rock, when you start to hear it moving and cracking and banging and knowing it's time to run away, so it's okay. As to why, it doesn't matter. If your experience is that the rock is talking to you, whether or not rock really talks or not, the phenomenon and the way you interpret it and your reaction is a heuristic approach to an imminent collapse. So let's just for a moment think about risk management. When people talk about it, and can I just pause just for a minute? Can I just confirm you can still hear me? Because of course I can't see anybody, and I'd hate to be just here talking to myself. Can anyone just let me know? Yeah, I'm still here. Good, good, good. See, that's me with my risk management. I'd hate to sort of finish in another 15 minutes or something and discover there's no one there. That would be bad risk management by me. So, risk management. Whose risk are we talking about? Like, who's it the problem for? And I've said in this case today, when I'm talking to you, I'm actually talking to you as individuals, to you as people, as my colleagues, as my friends. So I'm talking to you and saying, look, this is what I'd do if I was you. This is my advice to you. But of course, out in the workplace, it might be risk management for the client, it might be for the contractor, it might be risk management for the financiers, or as I've got here, the dot pointer, it might be yours. So first thing with risk management is working out, well, who are we thinking about here? Because everyone's risk profile is a little different and how risk affects them is different. Now, how do we do this managing risks? Well, as I think many of you know, we hold risks workshops, and I'm going to talk to you about them. I often find them really funny, but anyway, I shouldn't talk like that, should I? Risk registers. it's almost like death by PowerPoint, but often a risk register is an even bigger and more enormous and unfathomable document than even huge PowerPoint is. But very important, risk registers. Risk assessments, terrific if you've got the right subject matter experts and they really know what they're looking for or can inform the risk assessment process. And of course, the other thing is to know what's going on in India, like what the articles say, like the professional articles, what's taught at university, what are the conferences saying? What about workshops like this? Actually, these things collectively are evidence of risk management practices and what's to be expected building and operating tunnels in India in 2023. Because actually, newsflash, it's us. We create these rules. No one else knows. It's not like if you talk to a lawyer, they say, oh yes, in law school, they taught me about stress fields, finite element analysis. They haven't got a clue about any of that, but we do. So actually, what they do as lawyers is they engage with us as a group and find out what is the current practice. How is it that you're meant to do it? And that's how they try and determine if one of us individually or as a group has actually failed in our duties and individually responsible or as our company's responsible. So I've got an Australian standard that I've referenced here only because I don't know if there's an Indian standard and I didn't ever find out. But there are a whole lot of frameworks around, and Australian one's one, there's ISO standards, what have you, on risk management. The Australian one seems to be quite widely adopted overseas as an ISO standard as well. And I'm not saying that just because I'm Australian, it's just one of the things that sort of happened. But you may well have other frameworks you use in your particular state or wherever in India. And also, as Indian engineers, you may well find yourself in other countries, which is something I haven't mentioned. And I work with a lot of engineers from India who are working overseas. And so when you're overseas, also you have to figure out what they do there. It's not good enough to just do what you do in India. You've really got to sensitize yourself to how things are done around there. So if you're in the Middle East, find out what they do in the Middle East. I heard you talking before in my introduction with the NFPA 130 and 502 standards. There's an American standard, but it's widely adopted in Asia. Not so highly regarded in Australia. So find out what the rules are for your risk management. And usually you'll get some sort of a schematic process diagram, something like this, where you have to establish the context. So, that's like I'm building a tunnel or I'm operating a tunnel or whatever I'm doing, and I'm in the Himalaya and there's a whole lot of faults here and we're going to be in deep ground. And we're expecting really high temperature and high pressure water, but we don't know where it is because we haven't been able to do all the boreholes we would have liked to. You do an analysis of the risks. You tell the client about it. See on the left, so you're talking to the client saying, hey, look, we've got some risks here. We can sort of monitor it. We're going to measure, I don't know, groundwater pressure. We're going to measure temperatures. We're going to, up the front where we're doing the excavation, we're going to be constantly looking at face pressure or whatever you do. You're going to be systematic about it. You're going to treat the risks that you've identified in some way, and this will go round and round and round. And in many respects, this is just a drawing of or a map of what an experienced person would do anyway, but it's like a formalization of it. So it helps people who aren't so wise and particularly a project, to have a process around risk management. And as these projects get bigger and bigger and bigger, having this framework and doing the monitoring and feedback and communications and rechecking the risks and then evaluating and ranking and treating, going round and round and round, is a really, really useful tool, even if in the end it's about being wise. And then you get these tables. I'm not sure. I'm assuming many of you have seen them, where you put the likelihood down the left side and the consequences across the top, and paint them pretty colours, um, and and this is used as a tool to help you with the management of your risks. Uh, I was very careful in the words I used. I said it's a tool to help you manage your risks. My friends, now I'm whispering in each of your ears, right? This is like me to you, little secret, little gem that I'm passing on, remembering that I'm, in addition to being a scientist, engineer, I'm also a barrister. So I know how to come hunting engineers, like going on a bit of an engineer, yeah, like a hunt. So I know what I'm looking for. And if I find somebody who says, Professor, I did a risk assessment and I did a table and I had likelihood down the left and I had consequences across the top, and I plotted it all out. We had a workshop and everything, and this thing that's happened, well, according to it, it was a unlikely, and we thought the consequences would be minor, low green, so I did nothing about it. And if that's all they tell me, it's a fail. And the reason it's a fail is because I want them to say, and in my experience, that was the type of result that I would have expected, or this is consistent with what I know, or it didn't come as a surprise. And if it came as a surprise, I want to hear you say it came as a surprise and we went and challenged it, we tested it, and in the end we were content with the low ranking, notwithstanding that event has actually occurred. The reason I'm telling you this is it's not enough just to do the process, because you're experts. Like, you're it. We are the people who do this stuff. There's no one who knows more about it than us. And our community, our bosses, the clients and everyone, they expect us to do a really good job. And so a really good job isn't just having a table with some coloured crayons and saying, oh yeah, well, my result came out as a low, so I didn't bother about it. You've got to do more than that. You've got to be professional about it. You've got to exercise your skill and care. So my message there is, I've called it, don't get sucked into a process vortex. Don't think that just going through the process means you don't have to be an engineer, a professional, to do your duty for your country, for your company, for yourself. So my advice as a simple country fellow, and you've seen I lead a simple, I've got my chickens in the backyard. I'll go get my eggs after I've done this presentation today. My lesson is, stick to basics. Remember your engineering first principles. Remember your experience. What have you seen? What have you touched? What do you know to be true? Because remember, before we spoke about it being a heuristic method. Heuristic it's a practical method. So if one of your tools brings up an answer that is stupid or seems stupid or doesn't make sense, challenge it. Focus on what's real, not some imaginary thought experiment. And the increased use of digital twins and all the various analytical tools doesn't mean that all of a sudden the world is virtual. It's not. The world's the world, and it couldn't get more physical than what we do. So the risk is that your digital twin is actually a digital non-identical twin. So if it's not making sense, if one of these twins looks a bit ugly, the one you trust is the real one. Don't trust the digital one. Trust the real one, because our business couldn't get more real. Remember that picture of the rock falling from the roof and killing a whole lot of people. Doesn't take a lot of rock to kill. So we've got to be real about what we're doing here. And of course, consider what the practice is wherever you are, whether you're in India or you're in a different region of India, or you're in the Middle East, or you're wherever you are. Find out how people do things around there, because that is also important, because that will be part of how you'll be judged if something goes wrong. Doesn't mean you have to do it like they do around there. Like, if you've got a better way, challenge them. But do it in a heuristic way. Don't just say, I've got a better way because this is what they taught me at university. Say, I think I have an alternative way. Can we perhaps run some tests or do a little do a mock-up or whatever and test this alternative solution to the problem, and see whether or not you've got a better solution. So that's lesson number one. So I'll give an example. So say we were doing some integrated risk modelling and we did, say, some computational fluid dynamics using, say, an off-the-shelf program like FDS. And we integrated that fluid dynamic modelling, that sort of numerical modelling, with some sort of a tenability fertility modelling tool. So we might put in some parameters for, I don't know, carbon monoxide or whatever. Anyway, as a fatal dose, what have you. Then you do your modelling and you do some sensitivity analysis in relation to death by varying the parameters, like say ventilation, cross section, cross passage spacing, what have you. You need to validate and quantify the outcomes. And if you do that, if you go through that process using this, so you've got a model, you're doing this sort of analysis, you actually have the ability to compare different alternatives. But you've got to be a bit careful because you'd want to check the literature, and there's literature around at the moment. I've just cited an example there of a recent conference in Graz where there are some questions around the accuracy of FDS smoke propagation models. And right now, so 2023, right now, for you, for me, for all of us, likely we would be expected to know, if you're into ventilation in tunnels, likely you'd be expected to know that the predictions of backlayering speeds for fires in tunnels using FDS are underestimated at low fire sizes and overestimated at high fire sizes. So that's the difference between using a model and just relying on it, and using the model and being aware of what the current state of the art is in the industry we practice. And we take the next step. What we're seeing now is systems being developed, or are systems being developed to operate our underground infrastructure using dynamic real-time risk modelling to give a risk level for particular configurations of the operational state. So you, and this is, I think, for us as professionals in this strange century of, artificial intelligence and the Internet of Things and what have you, where the systems that we are developing to monitor the activities that we're responsible for, but for actually operating safely, those systems are starting to have complex feedback loops that provide us with real-time risk model data. And I'll give you an example. So here's the Elbe Tunnel in Germany. And if I was in front of you, I'd be madly waving and pointing and all that sort of stuff. And in the top right, you can see a graph. And what that graph is showing in real time is the level of risk in the tunnel as a function of a whole lot of different inputs. And so as the traffic intensity changes, as wind speeds change, as availability of different systems comes and goes, whatever, the mix of vehicles, whether there are dangerous goods in there or not, the level of risk in the tunnel is displayed in real time, and an operator is given the opportunity to change the way they manage that underground infrastructure in real time in accordance with an output, which is a risk numeral. So I think this is the first time I've seen this. This was only recently I saw this, just actually towards the end of last year. And I could imagine something like this being developed even in construction, with real-time data coming from, say, torque on a cutter head in a TBM, or groundwater water temperature, or whatever the inputs, but actually converting it into a risk, some sort of a risk number, and then managing things dynamically. So that's all very interesting. And I've just spoken to you about it like I'm really excited. But, you know, in my experience, the world's really full of clever people, like so many of them. Like it's just like heaps of clever people, and they're really, really clever. And I meet them all the time, and usually they want to explain to me how clever they are, and I'm pretty impressed because they always seem much cleverer than me, and they've got being clever down to a fine art. So they always make me feel like I'm like the stupid person in the room. Like, yep, you're really clever. You're much more clever than me. I'm just pretty simple, really, compared with you. But I've got to say, I reckon clever is a bit overrated. I think I think today I'd prefer to hang out with people who are wise than people who are clever. I want to be with people who can question what they see and make an informed decision using the tools available to them. I don't really want to entrust my well-being to just clever people. I find them just a little bit, well, a bit too clever for me. As I say, I like wise. So give me wise over clever anytime. So, okay. So given I've said wise, what does that mean? Well, for managing risks and stuff in the underground, there are now some new contracts which help. So say you're wanting to manage ground risk, or say you want to manage, I don't know, particular events, or you want to manage the risk of getting approvals for something or what have you. You can have that in special contracts. You might think you can manage the risk underground by the brands, right? So you go, well, I'm I'm going to manage the risk in my project by buying the most expensive top brand stuff I can find. Really? You reckon that's going to manage your risks? Well, you might go, I'm going to manage all my risks because I'm going to follow the British standard because, like the British, they're really clever, and the British standard would be a really good idea. So if I follow that exactly, that'll make sure there are no problems here or whatever. See, for me, all of those are nonsense. They might contribute in some way to the risk profile, but it gets back to this smart versus wise. So, okay, let's go have a look at the contract stuff. So in Indian law, as best I understand it after doing some research, the contracts can vary who has to do what and who's responsible for what. So it's not just that as a risk management tool, you've got a contract. It depends upon how the contract is framed and how you and your organisation are apportioned with risk under that contract, which is important. So, for example, it might be geotechnical risk. And although you might have a group of geotechnical engineers acting on different parties in a project, contractually, the the skill and care and diligence of one of those teams of geotechnical engineers is the one that really takes the risk. And so you need, when you're on a project and say you're a geotech engineer, you want to find out what your contract says, not just believe what you're told by your boss. You want to find out, hang on, am I responsible for the geotech here, or am I just checking, or what am I doing? Where, how is it that my expertise is on the line? So there's an example where it might be that the contract is a really good contract, but the wise part is figuring out how those contractual duties, as described in that contract, affect you, like you as an individual, not the big stuff, you. Because as I said, I want to talk to you about these things. And we've got some new contracts around. I'm not sure if you've seen this one, this FIDIC 2019 Emerald Book. It's really still quite new in legal terms, and it's a new first ever underground works contract. I know when I gave some advice to I think it was the Ministry of Power in India, There was a FIDIC book that was being used, but there was a Indian version of it, and that had changed a whole lot of the clauses. So again, just because you've got a FIDIC contract, if you fiddle with it and change some clauses, it's not a FIDIC contract anymore. It's something else. So the wise is checking exactly what your contract says and what impact that has upon you as an individual in discharging your duties under the contract, your particular professional duties. So then there's just stupid provisions in contracts. I don't know how many of you have seen this one, dry tunnel. Well, I don't know if any of you have ever seen a dry tunnel. Anyway, I haven't. But anyway, often in tunnels, and I'm telling you again, this is the wise thing. It's often a contractual requirement. And I'm sure for those of you who've been involved with TBM projects, you'll see, not sure if you can see my cursor here. I'd much prefer to be with you all and, waving my arms around and being like a real person instead of my little voice droning away. But if you can see my little cursor here, look, this has got 2 gaskets and, well, it looks very nice. The quality looks good. It looks pretty good. But actually, when I looked really closely at it, it's stupid. And the reason it's stupid is because in here, there's holes. And there's holes because there are bolts. So actually, there's a direct connection between this zone, between the 2 gaskets and the inside. So really, the only gasket, the only gasket that does anything is the outside gasket, not the inside gasket. But you as an engineer would need to know that. And here's a picture of a dry tunnel. I'll show you another picture of a dry tunnel. Here's another picture of a dry tunnel because the contract said it had to be dry. And I bet you in all the tunnels that you've worked in, all of you that are meant to have dry tunnels, they would have been to some degree wet, unless you happen to be in a place with no water at all, which I've never been in one with no water at all because usually, as I say, they're wet. So I hope what I've shown you is it's not about the contract, just about the contract, because the contract can say what it likes. You've got to understand the contract, but you've also got to understand what's real and what's not, like the wet and dry. You've got to understand what your roles, responsibilities and accountabilities are under the contract, and also in the jurisdiction that you're in, whatever country, whatever area of the country you're in, how things are done there. What about these big brand things? Using big brands as a risk management guarantee. So I'm not going to mention the names, but I'm going to make sure that in my project we buy big brand stuff because big brand stuff never goes wrong. Well, that's not true. Here's an example from a big brand TBM where the augers, all of the augers, fractured. So it's not about brand, or not just about brand. It's also about having sufficient insight into what you require as to be able to order appropriate technology, be able to inspect it correctly, make sure that it's fit for purpose, make sure that it's maintained correctly, make sure that it's inspected correctly, all that sort of stuff. So brand isn't going to do it. So big brands are currently under huge demand. And not only that, there's not enough of us as experts. Actually, the whole world is what I've called winging it, because COVID has devastated international flow of expertise, the supply chains, you name it, all in a big mess. So brand's not going to do it either. So I'm really popping a few bubbles here at the moment. I'm saying contracts aren't going to do it. Standards aren't going to do it. Brands aren't going to do it. Doing risk assessment tables isn't going to do it. So what about if we have commercial drivers then to do it? So what if we manage the risks by incentivizing with business drivers? Well, how does that really help if we haven't got enough experts? How does it really help if there are these hard deadlines from clients and we just can't do it? And how does it really help if all that happens is we get huge liquidated damages, money penalties, if we actually can't do it, we can't actually do it. So I reckon at the moment, my sense is I'm seeing some of the best consultants do some of their worst work at the moment because everyone's so stretched with the amount of work that's around the world at the moment. And I'm sure it's the same in India. I mean, when we talk at the end, we can talk about this, but I think we're really stressed and we've got to get real and get wise as an industry and amongst ourselves about how we do our projects. So the standards, well, maybe the standards is a good way. Maybe if we follow the standards, that'll sort everything out. And you heard in the introduction, I sit on the standards. I've sat on the standards for years. I write them, I criticise them and all the rest of it. And I'm not a god. I write standards, but I'm just doing my best. And the other people in the room are just doing their best. And we try really hard, but we don't get everything right. And they're a generalisation. So yes, it's great to have a standard because they're specific. They define things. They do all sorts of great things. But in the end, our projects are getting. So you've got your standards, but everything's getting so complicated. So yes, you've got a standard, but now we've got really complicated projects. We've got clients that are finding it difficult to get the experts on their sides. We've got constructors and consulting. Anyway, everyone's finding it a bit tricky. So actually, everything's getting harder and harder. So I'll give you an example that's actually quite a simple one, and it doesn't matter if you're in trains or roads or what have you, but how far are you going to stick your cross passages apart? What are we going to do? So I just thought I'd show you something here with cross passages, just to highlight standards and also to highlight some of the obvious silliness that there is in standards. So if we go to road tunnels, cross passage spacing maximums, United Kingdom 100, Australian standard 4825, 120, NFPA 502, 300, Germany 300, France 400, PIARC has an each way bet, 100 to 500, and China somewhere between 250 to 500. So what does that mean? Does that mean that tunnels in China are all bad? Does it mean that tunnels in UK, road tunnels, are all good? Does it mean that Australian tunnels are all good, but not quite as good as the ones in UK? I mean, of course, that's nonsense. But it just highlights how, again, the answer isn't just in a standard. Look at that. Look at those cross passages. And for those of you with experience building cross passages and how difficult they are and the dangers in cross passages, I look at this and I go, oh my lordy, did anyone even think about the risks to the poor people constructing these cross passages at, say, 100-metre separation when we're in bad ground and the cross passage construction is so difficult and dangerous? I'd say 70 to 80% of my disaster investigations are on cross passages alone. Cross passages always seem to collapse and kill people and just horrible things. So I just bring that as an example. So, my friends, I know this is very old-fashioned, but a possible solution to all of this is really have a think about, focus on clear thinking. Not just about compliance with a standard, but thinking that, that old-fashioned, kooky, rather unfashionable thing, but to actually have a breath, have a little think, and ask yourself, does this seem right? Does this make sense to me? Is this okay? Maybe I could speak to somebody? Because remember, engineering is heuristic. It's not science, it's heuristic. We're getting practical solutions. Is this practical? Does it make sense? Is it going to work? Am I feeling comfortable about this? That is one really good solution. And the reason I think that it's a good solution, there's a few that aren't so obvious. One of them is that low probability, high consequence events are poorly understood, even in maths. So actually, I know this is heresy, but actually, for low probability, high consequence events, there is a place for being wise. And there's also a place for questioning historical data, which is poorly understood. the geological conditions in any tunnel that you're building, unless it's the parallel tunnel to the one you've just completed, is likely to be quite different to the tunnel you did before. Certainly my experience, and it's very limited in the Himalayan context, is the rock changes so quickly. That's what's common, nothing else. It's the change that's common. It's not consistent. It's not like it's sandstone for the next 3 kilometres. It's not like we're in an aquifer now and we're going to have a water problem. Like you have a whole textbook of geology in the next 20 metres. Learn your whole life's learning in 20 metres in your drive. So the devil is in the detail. It's dumb to turn your mind away from this. We're in a very, very practical, very, very serious, very, very potentially dangerous environment, and we've got infrastructure to build. So let's think as engineers. That's all I want you to do. I want you to do your job as an engineer, not just run the software, not just not just follow a standard, not just that. I mean, yes, follow the standard, but engage brain, because that's what we're there to do. And if you're interested in the maths behind this, I wrote a paper with a colleague of mine, Lucas Ferkel. It's a bit old now, but I'll send a reference to it, and it explains mathematically why some of the things that are customarily done in engineering with our risk assessments from a mathematical point of view are just nonsense. So, for example, consequence down one side and probability on the other side. Hello, like who did maths? How can you multiply lemons with apples, get a number and think that that's useful? It might have a bit of use, but mathematically it's a nonsense. It's a crude tool to help us. It's a tool to guide us, but in the end we have to be wise. So I'll give you another example. So on risk assessment, rolling stock fires, we do, say you're building a metro, say you're doing a, I don't know, Delhi metro extension, what have you. Probably the best data available in the world right now for Delhi Metro is Delhi Metro data. Because if you go back through all the train and subway fires, and this is just a list of them, how can you compare the data coming, say, from, I don't know, Kaprun, the funicular railway, with the Delhi Metro fire? It's nonsense. Of course you can't. Or the 1995 Baku Metro fire in Eastern Europe, which is an underground railway. So you might think that you can compare that data with Delhi Metro. No, you can't. Have a look at what Baku Metro's got. Really ridiculously old rolling stock. I think it even has asphalt on the roof. Like, it's just garbage rolling stock compared with what you're running there in Delhi. So you shouldn't use the data, because yes, it's available and yes, you can plug it into your model, but it's like putting elephants in one side and grasshoppers in the other and then multiplying it and thinking you're going to get a butterfly. Like, it's just, it doesn't make sense. And again, as my new best friends, what I'm saying to you is, as professionals, we're trained to be better than that. We're trained to actually turn our minds and be wise and clever, but not too clever, be wise. And that's what I'm asking you to do. So don't let your risk assessments become a risk management smoke screen, because actually you don't know what you're doing. Right? Don't let that happen. If you're out of your depth, ask someone for help. And so that's okay. Like, that's what we do. Because if you get your risk assessment wrong, you might prioritize your resources wrong, and you might end up causing a big problem that'll come back and haunt you. So then we're back to, maybe wise is better than smart again. Back to this idea of wisdom. Back to the idea of us being engineers. Back to the idea of us thinking and doing things in a way that our mums and dads and everyone will be very proud of, because we are the experts at this. This is what we're paid to do. No one else knows how to do this better. We're always whipping ourselves. Oh, God, we don't have enough data, and how are we going to do this or that? The fact is, We know best, even if it's not perfect. That's why I say our method as engineers is heuristic. But just keep it real with your risk management. Just keep your engineering real. The reality of the rock, the reality of the build, reality of your team. Who have you got? What do they know how to do? How experienced are they? And revise your ideas as new evidence reveals itself. So back to our collapse. So if you have a look, we've got this lattice girder in here. And if you have a look there, I don't know if you can see it, but there's a little dark layer there. And when I went and looked at the cores, which were taken just a very short distance away from this cross passage, in the cores, I also found a tiny little dark layer. And my friends, it only takes a tiny little dark layer for the rock to fall from the crown in the roof. That's how you kill people. And in some areas, what we call that is coffin cover, because just a very thin little bit of silt is all it takes for that block of rock to fall out and squash the people below. Like that. Like that. And that's me. Being very serious, of course, because obviously some people have died. That's my daughter, Hannah, who I'm very proud of. She's working with me. And so that these people were part of my team. And this lady here actually also from India, and she was absolutely instrumental in the investigations because she was, well, because she's a she, and because she spoke Hindi, she was able to speak to some of the people that weren't killed, and they were open and honest with her about what had really happened. So she was our secret weapon, and that's Dina, and Dina was our secret weapon in the investigation for this particular multi-fatality incident, and that's about whys. Right? That's what I'm talking about. That's about knowing that if you've got a whole lot of men who are scared, then get yourself a woman to talk to them and find out what really happened. That's wise. In this case, might not work in all cases, but it worked there. Dina's awesome engineer. She's my top. She actually ran the engineering team in wherever this is that we are, wherever that picture's from that I can't tell you. So back to Mecca. So the pedestrian tunnels. So here we are in our pedestrian tunnels, and we've got an operational tunnel here. We've got jet fans here. We've got nice lighting, and everyone's busy. We're going off to do our Hajj. You can see we've got our safety officers here. I don't know what they're going to do, but anyway, whatever it is. And this is to give you an idea. If you haven't been to Hajj, it's quite a lot of people sort of wandering around in the same direction, going through the tunnels, what have you. Actually see them heading into a tunnel up here. This is, I think it's the largest annual migration of human beings on the planet. So a lot of people. But when something goes wrong, kill a lot of people. So in this case, in 1990, more than 1,400 people killed in a tunnel for no reason other than they started to fall over and get scared. An operational problem. And it looks something like that. So then the question is, if you were the engineer who's responsible for the preparation of that tunnel, converting it from the use for cars and to use it as pedestrians, what could you do practically, not on some computer simulation, practically, what could you do to mitigate the risk of a stampede killing a lot of people there? That's a practical question, and you might use modelling to help assist you, but get it wrong, and that's what it looked like. So my conclusions. Wise is better than smart. Widely accepted practices in India can be a solid base for action. If you've got a contract, which you should have a look and make sure you understand what's required of you professionally. Don't be fooled by brands. Just because you've got the best brand doesn't mean things aren't going to go wrong. Just because you've got what you think are the best standards, they're just generalizations and they're a poor cousin to reality and good engineering. So question your standards. I'm not saying don't follow them. I'm saying as a wise engineer, just be on alert where you think that the standard is wrong. Risk assessments, they're a tool. They're a tool. They're not a substitute for you. They're not a substitute for wise decision making. Concentrate on how you think and solve problems. And risk management can involve useful thought processes, but ultimately we have to take action because we're engineers despite imperfect information in the face of uncertainty. And the challenge is that the law, and it's the law in India as I understand it as well, and I'm just going to read this, and because I think it captures some of the outrage when people are killed and some of the burden that's on us as engineers, and that is the common law. So that was obviously the law when the Brits were, in India like they were here. We got rid of them. I think you've got rid of them as well, so that's good. But anyway, when the British were here in the common law, it's always attached fundamental value to a human life. It's attached a fundamental value to a human life, a value originally based upon a religious idea, although often now it's no longer accepted. But in the early commentaries legally, human life is often described as an immediate gift of God, a right inherent by nature in every individual. And so that fundamental thing, a right inherent by nature in every individual, seems to be a common theme, and that is that human life needs to be respected and that we should respect all of us, all of our colleagues, our users, the same level of value upon them in terms of their life. But this is an ethical question. It's not an economic question. So the value, and one of the judges, I think quite funnily said, I think this is humorous back to me being a jolly folk, the value of human life, which is universal and beyond measurement, is not to be confused with the joys of parenthood, which are distributed unevenly. And for those of you who are parents, you'll get the joke in that. So this is just my thought. So underlying what we do as professionals, in the end, we are part of the guardians of human life, both in construction and operation. And that's why we have to do our job so carefully. And that, my friends, is my little chat with you. I mean, I'm hoping you're still there. I can't tell because it's all blank in front of me. But if you're still there, I'm happy to chat. If you've got time or you'd like to talk to me about anything, my presentation on risk assessment in perhaps a different way than what you would often have it heard.
Thank you, Professor Dix. Now we'll go for the question and answer session. So we have one question regarding what type of software is used for this risk assessment during in tunneling.
No, well, I haven't seen it. I'm saying I think that's going to be the next step. I think what we're going to see is like what I've seen in the operational context, where because of the Internet of Things and the way a lot of our equipment now has got instrumentation on it, I think we're going to see that. So you would develop, and probably India is a really good example of a country that could develop real-time software to provide feedback on level of risk during construction. So you might have strain sensors, you might have water ingress sensors, you might have torque sensors on your equipment, and actually integrate it and give a live output as to where you think the risk's at. So it doesn't exist. I've only seen it operationally, but given, for example, the Heron Connect TBMs are going to fully artificial intelligence control, so fully automated TBMs in some environments, that that type of feedback on risk is part of that AI augmented, fully automated, no crew on board TBMs that are starting to work around the world now.
So next
Yes.
question is
Yeah.
from Mr. Sachin, who is from MIT, and he's quite excited to be here in the webinar. And he asked that with uncertainties and unintended consequences being associated with underground projects, public awareness and perception management have become the buzzwords. Sir,
Yeah.
what is your view? Are the methods and programs that professionals can adopt to support for the underground and tunneling projects?
Yeah, he's right about that, because a lot of our projects, in fact, not the majority in India necessarily, but in many parts of the world, are in very urbanized areas. So the trend I'm seeing at the moment, and this is probably this decade, so really it's come about sort of 2020, 21, 22, 20, now to 23, is engaging with the community before a project and not discussing the tunnel so much as discussing the outcome. So you engage with your community and you say, we've got this fantastic project and we're going to be delivering, and insert what it might be. It might be fresh water, it might be sewage, it might be a new transportation solution, it might be a drainage solution, it might be whatever the solution is. And you say, and we're going to give you, at the end of this project, we're going to have better health and better public open space and better all that. So you talk that first and get community engagement, so that the community, even before you talk or expose them to what we do, actually are a bit excited about it because they think things are going to be maybe better. And then, of course, you've got to deal with things like the vibrations and obviously the damage, potential damage to properties. So doing the early surveys of properties so you can tell the difference between properties which have really been damaged and projects which, everyone's trying to get money out of the project, hasn't really been damaged, but everyone's claiming it. I think projects have to have a strong position in advance what they're going to do if something goes wrong, so it doesn't catch them and their leadership team off guard. So, what if some people say, look, it's keeping me up awake at night. I can't sleep with the noise. It's coming up through my foundations. So having a position on that in advance where you say, oh, okay, well, you can come and stay in a hotel. We'll move you there. And then you've got the trucks and everything in the streets. So, really, that sort of impact in terms of muck and everything, working that through. I think it's every project needs us as engineers to step back a little and be thoughtful neighbours and responsive to the community. So I'm not sure. I don't think there's a single answer. It's more the times have changed, and you can't just impose your will on a community. You need to engage with them. And some of the things that happen with our projects are horrible. Like, if there'll be some people who will be affected by vehicle movements or anyway, so that's what I'd be suggesting, that lift our game and be more community minded in the way we engage with our communities if possible.
Thank you, Professor Dix. We have another question from Mr. Sachin himself. He says that impact assessment and assigning weightages to the risk is mostly based on the perception or experience of the individual and mostly influenced by the employer, the client, the consultant, contractor, etc. He requests you to advise on how one can be heuristic and convincing, reasonable in undertaking the above.
Yeah, so it's a really good question, that one. What I've seen, and it depends on the clients, is sometimes a client can be persuaded to set up, in some countries it's called like a peer review group or something that sits a little bit outside the client or the contractors or any one of the parties, and just checks to see whether what people are saying makes sense, and to make sure that we haven't got one party who's really driving the issues unreasonably in a particular direction, which of course threatens the whole project, because if one party is unreasonable in the way they identify, manage, prioritize a particular risk, it threatens everybody who's involved. So that's one strategy, where you have this amorphous non-party group who you run things by to make sure it makes sense, like a wise person's check. Um, and yeah, apart from that, it's always the risk that one one party would be more dominant than another, and sometimes personalities are domineering, even though the people who are the loudest and the most domineering aren't the clever ones. They're just the noisy ones. So that's also a problem. I'm not sure. I haven't worked enough in India to know that about that culture, but certainly, like I've just come from a meeting in America, and I was just staggered at how rude some of the people were in the meetings. And I didn't think that they were particularly smart. I just thought that they were particularly loud. But because they were so loud, people listened to them. So I think that, again, that gets back to being wise again. Some sort of the ability to take a breath and reality check. Getting back to what I spoke about, heuristic methods. What does this really make sense? Does this accord with my experience in these things? Would the community? Do you think it's true, or is someone twisting the truth a little here to get their approval, or minimise the costs of their pre-construction works, or whatever it is? That'd be my reaction in the abstract. And in practice, in the actual project, it's about managing that project and the personalities and expertise in the project. Okay, I think that's about all I could say in the abstract. I really don't like being like a voice. I'd much prefer to be in front of everybody. I promise oh, sorry, there I am in front of you. Sorry, I was leaning into my
Yeah.
computer. Hang on a minute. Yeah, sorry. Okay, I'd forgot. I was leaning right in. I'm like doing
Yes.
imaginary. Okay, I'm back. Sorry, I'm looking at you all. Hold on, I'm here
Yeah.
now again.
So,
Sorry.
thank you for answering the question. Now we have a question from Mr. Prashant. Uh, he asks, what is the way to filter risk based on analysis that is currently being done by few engineers who think that if they have modeled something in a particular software, it automatically takes care of it. Some of the clients less consultants become fuzzy for the result coming out of the software at 100% accuracy, whereas in real terms geotechnical parameters used may be off by order of even 100%.
Yeah, I think this has absolutely nailed it, that question. This idea that because we've got software and the software gives what appears to be an accurate answer, without any error bars around it, without any sensitivity analysis, without really any understanding about what's driving that particular outcome, it's getting up towards the nonsense area. It might be persuasive in a meeting with non-engineers, but it's very dangerous. So in maths, for example, there are things called, I think it's called vortex, when you do numerical vortex. So one variable might actually drive the outcome of your risk model enormously, because there's like a numerical vortex around it. So it gets back to what we were talking about before. If you accept what I'm saying, that engineering is heuristic, it's practical, then the risk tools should just be tools to assist us, and our experience and wisdom should be, in the end, taking a much higher priority. So you need that experience in the room to say, you know what, I don't think so. I don't think the risk so what would be an example? Say during construction, damage to second story buildings or what have you, and you go and you have a look and you think, well, I think this is overestimating, or having some judgment. Anyway, I think judgment is really important, not just the numbers. I don't have a solution. I mean, that's the trouble. That's why I'm saying our methods are heuristic. We pretend we're scientists, but we're not. We're building big, ugly, not ugly. I mean, I love them. I think they're beautiful, but we're building great big holes for doing stuff. And despite all of what we say, we're not at 0.000% tolerances and what have you. Maybe in the surveying we are, but everything else, there's quite a lot of, or there should be quite a lot of give and take in our methods and calculations, because that's what makes them so strong and reliable. Because we don't really understand all the variables in the underground.
Yeah, it is quite like we cannot predict it to 100%. Yeah, you're right.
Yeah.
So we have a question from Nimil. Can you explain an approach for assessing fire condition in road and rail tunnels?
Yeah, I can. How many hours have we got? So, this is it's my favorite. Like this, whoever you are out there, thank you for asking that question. I think this probabilistic fire analysis stuff is one of those areas of tremendous interest and some degree of witchcraft. And because a number of the variables around it are they're like vortex. They do drive the solutions in different ways. So sizing of the ventilation capacity, working out how we control smoke management, whether we're going to use active fire suppression, are we going to put in passive stuff? Are we going to allow dangerous goods? Does it just have cars? What's going to be the impact of new energy carriers? Are we going to let dangerous goods? All this stuff means we we do have to be systematic. And so yes, I can't say I prefer method A or method B, but I can say it requires a great degree of attention, because if you don't do it correctly, we tend to over design, and we tend to be way over design, and we tend to be very, very pessimistic. And I don't think that that's useful, particularly for our countries, because we end up spending too much. Sometimes we end up spending too much on our assets. I don't know what the current situation is in India. So, but in other countries, I'm seeing a lot of overspending. I just came from a tunnel project in where was I? I might be able to show you actually. Oh no, it's too hard. But I was in Poland, and they just recently built a really wonderful tunnel, but it had everything in it. Like it had virtually everything you could buy in it, and the energy consumption was huge, and the peak energy consumption was huge. And I don't think it made it any safer at all. So again, a bit of a systematic approach and being wise with your engineering. You don't have to spend more and do more to get safe and resilient infrastructure. I hope in some vague way that helps with an answer. I can't, but I can't spit out a methodology. Although I did use an artificial intelligent robot to answer that question the other night, one of these AI bots, and it spat out a methodology. It was pretty good. I just put in describe a methodology for the assessment of fire and life safety risk in a road tunnel of 3,000 metres long with 3 lanes of 3.5 metres wide in 1,500 words or less. And in less than a minute, they spat out a pretty good methodology. I was a bit shocked. But is that smart? I don't think it's smart. I think it's just a robot saying something. So we get back to wise again.
Speaking on AI, I have a question from myself. Like, what will be the role of AI in predicting the in risk assessment and all in future?
Yeah, I don't know. I so the AI that I've used hasn't got. I've got the AI access to the AI, which is only accessing technical information up to about 2020 or 2019. So I haven't played with the AI that's actually alive and actually sort of scouring the world for information at the moment. So I don't know, but I I think my sense is that it will suffer from the same issue that we suffer from as a species, and that is that the data the actual data that it will rely upon is flawed because the data sets, the historical data sets like in metros or roads or hydros or whatever, it's not directly comparable. And so the AI will probably be full too. So I think there's still a place for wisdom to analyze what an AI comes up with because I don't think the AI, I don't know, maybe the AI will be able to soon, but I don't know that the AI can tell better than we can about the applicability of the historical data sets that it relies upon for its predictions of such things. But I mean, my goodness, if I hope all of you have been looking at this AI stuff, because I've said to my family, the world has changed. Like, put this in your diary. The world just changed because suddenly data, virtual data, is is no longer something you'd want to have a job in because a robot can do it. Where you want to have a job is like what we do. We want to be building tunnels or in medicine or doing real substantive things, not just playing with data, because the robots look like they can do that quite well.
Yeah,
Yes.
rightly said. I also had the same thought when we are coming across many AI platforms nowadays, right?
Yeah.
So we have a question from Vaishnavi. She asks that how can risk assessment be integrated into a design and planning stages of tunneling and infra projects? What challenges exist? Also, how do we account for uncertainties and unknown inherent in the projects?
Yeah. Well, I'm hoping my presentation gave a few clues to that. I think, of course, you have to have a systematic risk assessment process in your projects. And for those of you who saw my LinkedIn post, I think it might have been this morning, my time, we were having this discussion with the World Bank yesterday. They had 300 of their World Bank project delivery people on the line, and we were talking about systematic risk assessment. And I think from that discussion with the World Bank, what struck me was subject matter expertise. There's no substitute for subject matter expertise because a risk assessment in the abstract doesn't have the wisdom. And so it doesn't matter how many people you've got in the room performing a risk assessment and deciding what the probability and likelihood of a particular event is, or even defining the event that you want to analyze is, if the people in the room don't know, your risk assessment will miss it. They'll just miss it. So um, I think this gets back to the us as professionals. Yes, we go through the systematic process. Yes, it's revealed in the project documentation. Yes, it's part of the approvals. Yes, it's part of the project. It's dynamic. It's alive. We use all those words, and most importantly, we think about it. Does it make sense? Is it what we're seeing? Are we seeing that there's subsidence out there? What are our instruments telling us? What's happening with our water table? Does our risk analysis and the model that we've built for our aquifer behaviour, is that performing as we expected or not? And if it's not, what are we going to do? That sort of thing. I think that's what we're going to see more of. So it's integrated, but more clever. And I saw that actively done in Copenhagen Metro, where groundwater was a big issue because they basically built it on a swamp. And so the methodology involved sustaining, not draining, but actually sustaining the ground level water height, and then predicting any variation as they actually excavated. And as soon as that prediction went different to what they were measuring. It was like emergency. What's gone wrong? Why isn't this going according to the model? And there'd be people in the tunnel having a look for leaks and checking the instrumentation for subsidence and what have you. So I think that's what we're going to see: sort of smarter integration of tools and monitoring and response. That's how I see it. And in the end, keeping it real, because it doesn't matter what the robots say. A rock is a rock, like a subsidence is subsidence. House falling down is house falling down. Getting killed is getting killed. It's like couldn't get more real.
And we have a question from Mr. Chirag from MIT. He's a student. He asks that he's asking that He wants to know what is your advice for students like him who will be joining the industry soon, and how to keep up with the same intent of being wise at the site as yours.
Ah, well, Mr. Gerard, first thing you've got to do is come to my talk when I'm at MIT in a few weeks' time. Now I can meet you and we can talk about this over a coffee. Um, I think one of the big tricks is not getting old and thinking you know everything. So um, I I'm old, but I'm always wanting to go on site. I'm always wanting to talk to people. What I do is and maybe I'd suggest this for other people who are on the call, get yourself involved even in peer reviewing papers or get yourself to conference proceedings or anything that keeps you immersed in the latest thinking, the latest events, the latest disasters, keep involved in the industry as as I spoke about before, if you accept that we're a heuristic profession and we really don't fully understand what we're doing, but we get really good results, then just like the lime juice for scurvy, greater and greater understanding of what we do emerges in time. So it's really handy to have a finger on that pulse, no matter what stage you're at in your career, so that you can both convey your experience to someone else and also you can absorb and synthesize the experiences of others. So yeah, my advice is consider yourself always at university. You're always at MIT. You're just going to go off campus for the rest of your life. That's all. That'd be probably my advice.
Yeah, thank you, Professor Dix, for your wonderful webinar on risk management. And we had a quite a good turnout of this young members today. Like
Right.
it was the highest number of turnout we had today
Oh,
regarding the young members. Yeah.
oh, fantastic.
Yeah, we have this webinar open for everyone, for all the tunneling professionals in India, but young members are quite huge in numbers today.
Yeah.
And I'm sure that your experience will be useful for everyone. And I would like to inform all that we have all our webinars on YouTube, so we you can go through them as well.
Are you going to
And
cut? Are you going to cut the bit out about my chickens from the beginning?
yeah, we will just start with the part where we start the webinar.
Okay, that's good.
Yeah,
Excellent. Okay.
yeah.
No, I
And
just gave me a heart attack there for a minute.
no, we usually start the recording or the update on YouTube after the webinar has started. And
Okay.
yeah, we thank you once again, Professor Dix,
Thank you.
for being with us. And stay safe
Thank you.
and have a great weekend.
I will. Thank you, everybody. Enjoy your weekend as well. And thank you for having me as your guest. And goodbye from Australia.
Yeah.
Okay.
Bye. Thank you.
Bye. See you later. Bye.
Bye.